Hey everybody. So today I just want to do a quick video about basically some open source, free if you want to use this. What they are is basically LoRa drivers. So if you want to, from LabVIEW, leverage, and I'll show you the specific hardware I'm using. This isn't going to work on every device, but it will work on these. Is basically a way to take serial commands and convert that to LoRa, and then receive data over LoRa and convert that to serial. And if you don't know what LoRa is, essentially it is a radio. And I'm not an RF expert or anything, but it's basically like a lower frequency RF communication method that it's long range. It's meant to be very long range, and also very low power. So your devices that use LoRa are very low power, but it can transmit really far distances, and it's all wireless. So this is the actual device I'm using. And full disclosure, right, the inspiration for all this and everything came from Steve Watts. He's actually the one, he made a YouTube video the other day about these. I thought it was really cool, so I went ahead and bought 2 of these on Amazon. They're only $15, so pretty cheap. And if you're interested in his video, I'm going to include the link to his video in the description of this video if you want to go check it out. But yeah, that's where I actually got the inspiration for this from. But yeah, so this is the device. Comes with the little antenna kind of built in. It's actually really, really small. I don't know if it has dimensions on here, but it is very, very small. Yeah, you can't see that great. But yeah, and then basically just have your pins here, and it just basically converts LoRa to UART and UART to LoRa. So yeah, it's got its own little chip in here that's just receiving and transmitting data, and then you can issue commands to it over the serial interface to read and write data and configure how this thing works as well. So this is the exact one I bought. Rayax actually has a couple. I think they have 2 different modules that are similar. The drivers will work with either of them, so yeah, but pretty cheap. And then you just need some sort of like TTL converter, which those are a couple bucks on Amazon, if you want to be able to convert that to like USB to plug it into your computer. But yeah, so I've gone ahead and I've mapped all of the commands for the device. And I built this into a LabVIEW class. So we've got our initialize device function, which basically just instantiates the class, and then sets up the serial port and everything for communications. And we've got a closed device when we're done, and all this really does is the Visa close for us, so nothing crazy there. Then in the commands, so for configuring, there's a lot of different commands you can use to configure this device. So I've mapped functions so you can read all of this data, but you can also set this information. So you can set the address of your device. So anywhere from 0 to, I think it's like 65,000, whatever the 32-bit integer ends up being. I forget the max, but really big number. So you can set the address of your device. That way you can connect from one LoRa device to another LoRa device by address. So I can say, hey, I'm looking for device 17, and I'm sending that message to device 17. I can set the baud rate. So if I want to change the baud rate, by default it's set as fast as it can go. But if you needed to lower that for whatever reason, you can. You can set the mode. So this allows you to set either transmit and receive mode, which is the default, which means it's actively working, or you can set it to sleep mode. So it just goes into like sleep and consumes even less power. So yeah, you can set the mode. You can set the network ID. So this is meant so you can basically put certain LoRa devices on an independent network and they can talk to each other. So 0 is kind of your public LoRa. So anything and everything can all kind of reach each other there. But a lot of times, right, you might want to have like a private group. So you're not, if especially depending on the data you're transmitting, right? You might not want someone else to accidentally receive that data. And yeah, so this is just a way that you can move to a different basically network, and only stuff on that network can talk to each other. Output power, so you can set the RF output power. You also can set a password, so that way basically I can pull up the documentation here. So it is an AES 128 password, so it needs to be 32 characters long. And then basically only stuff that has that password set on the modules can communicate with each other. So it's basically a way to encrypt your communication, so that, yeah, my sender and receiver both have to have the same password set on the devices in order to be able to transmit that data properly and be able to actually interpret it. You can also set the RF frequency, so you can just go update that. There's default settings, but if you want to go at like some custom frequency or whatever, you can. And then there is, you can set the RF parameters, so spreading factor, coding rate, program preamble, and your bandwidth. So, and I've mapped all the options of different bandwidth that you can specify. Just look at utility real quick. I do have this factory reset. So if you change a bunch of settings and now your device is all screwed up and it's not working very well anymore, you can just run factory reset and it resets it to factory. You can read the firmware version. You can read the unique identifier of your device. You can restart it, doing like a software restart. And also this just does a test to make sure you can talk to it. So make sure you hooked up all your serial communications correctly and everything. So yeah. And then I do have some private functions. So this error handler just reads the response. And there's a whole bunch of defined errors in their manual. So I've gone ahead and basically mapped these and then converted those to basically LabVIEW errors that we can pass over like an error wire. So if the device returns one of these errors in its response, it will automatically go and map that to a LabVIEW error, and that's private. I have this parsed received data, so when you receive data, it returns it in a certain format. This is actually parsing it and then just converting it to this cluster. So you get who sent it, how long it is, what the data is, the signal strength, and also your signal to noise ratio. And there's also just this request and response that all it does is write serial data to the device. It waits however long you've told it to wait, and then reads however much data is at the port. And yeah, there's your little error handler just to check if there was any error codes returned. Yeah, pretty much everything else, right? That's all the configuration stuff. Pretty much everything else, all you really need to use is this send data and receive data. So the send data, all you need to do is specify the address of where you're trying to send it and the message you want to send. And that's pretty much it. And you do get a confirmation back from the device if you got that successfully. Yeah, that's pretty much it. And just as a side note, this can only send a max of 240 bytes. So you can only send 240 bytes per message. If you need to send more than that, then you're going to need to break it up into multiple messages or something. And then for your receive data, yeah, this is actually just querying the module to see if we've received any LoRa data, and then it will return the latest data, and you can go parse that. So pretty simple. And then the read sent data just returns the last data that you sent, right? So on this device here, the last command you sent, it will basically return that to you. So you can see that. So that's pretty much it. It's all just wrapped into a class. The class doesn't really have too much to it. It's just storing the VISA reference and also this read delay. So yeah, nothing super crazy. But yeah, and then I'll just show you, I have some tests. So I have a LoRa reader and a LoRa writer. So just show you how simple this is set up. where we basically just have 3 VIs, right? So this isn't including configuration and all that. So if you need to configure a device, you'll need to add more functions. But once you have your device configured, you don't need to mess with all that stuff. So then you just have your initialized device, pass in my Visa resource name. There is also this read delay, which I have the default set to 20 milliseconds. If you want to change that, you can pass in whatever. It's an optional parameter. If you don't pass it in, it's gonna just be 20. And then also the baud rate. So the default baud rate is this one. So if you don't wire that in, it's gonna assume you're using the default baud rate. But if you've changed that baud rate, then you're gonna need to go in and pass in the correct baud rate. That's pretty much it. And then for the send data, we just need to specify the address we're sending to, which 0 is basically publish, send it to every address, and then just pass in our payload. So we're just taking a random number, flattening it, and writing it. And we get this to make sure to let us know if we were successfully able to get that command on the module. Do that over and over again until we close the device. And that's really all it is on the writer side. And on the reader side, it's pretty much the same thing. We're initializing the device, same options. We're receiving data over and over again. And that data is, like I said, it is this cluster that with all this details. And then the data is a string, and I'm just converting that back to a float because I know that in this case it is a float, and graphing that. And that's really all it is, right? And then you can basically wirelessly transmit and receive data over long distances. It works great outdoors. It works okay-ish indoors, especially depending on your facility and what it's made out of, what's in between you and it. But I've had decent success getting this working indoors. And then that's pretty much it. Like I said, this is all open source free. This is in my GitLab. The link to this is going to be in the description of the video if you want to play with it. I've got this up there, and then I did also include the manual for the device, the commands, but also I generated this class documentation document. So if you're interested, it has all of the functions, and it includes a picture of the front panel and block diagram and icon, as well as the description of all of these. So if you're wanting to take a look, you can go through this and kind of look through the documentation. So hopefully that's helpful. If there's anything you feel like is missing or would be nice, just let me know. I'm happy to work on this with anyone. Thank you guys for tuning in.
Canon Controls is your gateway to mastering LabVIEW. Dive into programming for data acquisition, industrial communications, and manufacturing automation. Explore how to enhance your projects with cybersecurity best practices. Join the journey to elevate your skills and secure your systems with every episode.